Okay, so here we go. At right is a picture of an Atwood machine, two masses attached to a frictionless pulley. The mass of block A is 5 kilograms. The mass of block B is 2 kilograms. So it's important to kind of like make a judgment here that this one's going to go down, A is going to go down, and B is going to go up. And that's the, I call that the direction of motion. It is the direction that they're going to accelerate also.
Yeah.
They don't always go in the same direction, but in this case they do. So is that okay so far?
Yes.
All right, so you have to make two free body diagrams. And what I do is I kind of bubble them up here. So for A, and you can even redraw it if you want. It's got the tension up and it's got mg down. And it's accelerated down. Okay. So we're going to call down positive. And it even said that, it said that somewhere in the notes that you should make the direction of motion positive.
Okay. So we got mg
So now,
going down.
Yeah, so you like I would go, it's a little weird because it's mg minus t equals ma.
Minus t. Okay. So we got redraw it. mg t. Okay. What's going down? It's acceleration
Yes.
for A, right?
Yeah.
Okay. So gravity minus tension equals mass. Is that what that is? On the right?
Yes.
mg
minus t equals mass times acceleration. Now, it's important here because the masses are different is to actually, I would actually put those numbers in. So put in 5 times g minus t equals 5 times a.
How come it's 5 times A?
Because the mass of block A is 5 kilograms.
Oh, okay. And
then we're going to do now we're going to do the system at B. So for B, you've got mg down again, you've got t up, but this time acceleration is up.
Okay. So you got tension right there, and then we got A going up. So are the solutions like similar?
Well,
like
this time you have to do you assume that positive is up because it's the direction of acceleration. So it's t minus mg equals ma.
Okay.
And this time m is equal to 2. So we can write t minus 2g equals 2a.
Okay.
So, for example, you could solve for t in this one. You want? That might be good to do. Solve for t.
All right.
So t is equal to 2g plus 2a. And then if we come back up to this one from the other one, we just kind of come down here and we solve for t. T is equal to 5g minus 5a.
5g minus 5a.
And then you can set the t's equal because the tension has to be equal in the pulley.
Oh, it does? Okay.
Yes, that's the important part of this. Now, why are the a's the same? Why are the a's the same in this? And it's because when you treat the whole system as one free body diagram, it's an acceleration together. Like it's not like they're disjointed. It's like you inside your car. You're not treated separately from the car.
Okay.
So the whole thing has the same acceleration. So we set these equal. 5g minus 5a equals 2g plus 2a. And perhaps at first glance, you're like, oh, I can't solve because there's two variables. But g is really 9.8. So we can add 5a to both sides. Subtract 2g from both sides. So we get 3g equals 7a. So acceleration is 3g over 7, which is 3 times 9.8 over 7.
Oh, okay. 9.8 over 7. me get my calculator out for that. And it's 9.8 times 3. 9.8 times 3 divided by 7. That should be 4.2 meters per second squared, right?
I got 4.2, yeah, and that's meters per second squared.
Perfect. All right. So for A, we were looking for the acceleration when the blocks are released. What is the tension in the string? So now do we solve for both tensions?
The tension is the same in the string. So that you can use either equation, you get the same result.
Okay. So 4.2 is the answer for this, right?
4.2 is the acceleration, and then the tension in the string. We can go back and use either of these equations. I'm going to choose the 2g plus 2a. Tension is 2g plus 2a. So 2 times 9.8 plus 2 times 4.2.
Oh, okay. Oh, that works together nicely.
Mm-hmm.
All right, so we got 9.8 times 2, and then 4.2 times 2, which is 8. All right, so 8.4 plus 19.6, and I get 28 for tension.
Okay. And what are the
What's
units?
Is the tension in newtons?
Newtons, because it's a force.
Okay. So then tension equals 28 newtons. That's for A. So now how long will it take for block A to fall 2.0 meters?
All right. So the question is asking about the block falling. We already said it goes down. This is a way of like going back to kinematics or 1D motion problems, because all you care about with this part B is that this block is moving down. It was initially at rest. Okay,
Yeah.
so it was initially at rest. So this block is moving down. Okay, and we want to know how long it takes to go. What did it say? 2 meters. Okay, it was initially at rest. When it's at rest, what is its initial velocity?
It's always 0, right?
0. Well, not always, but in this case, it's at rest at 0. We know its acceleration is 4.2. What equation governs one-dimensional motion or two-dimensional motion? Y equals y naught plus v naught t
Okay.
plus 1/2 a t squared.
The reason why, because it's vertical, right?
Yeah, this problem is the same as even if you were pushing it sideways. But I just
2.0 meters, and so V naught at rest. So V naught is 0. A is 4.2. So Y equals Y naught plus V naught plus 1/2 a t squared. And is Y naught 0?
yes.
Okay. So Y naught and V naught can go away, and we just have 1/2 at squared, right?
Yeah. So we're y is 2, it's 1/2, and then acceleration is 4.2 times t squared because both of these are 0. So you're solving for t squared.
1/2 times 4.2 t squared. Okay. So 2.1. All right. So 2.1. So 2 divided by 2.1
And the square root of that.
is square root of 0.95. Should end up being 0.9759 or something.
That sounds right. Yes.
So that turns it to t equals 0.998. That's what I end up getting. Seconds. Is that the answer for this one? Just time?
Just time. That's all it's asking for.
Perfect. All right, so I have that. All right, now I can go to number 10.
All right, so you ready to move to the next one then? Any questions on it?
Yes. Pretty straightforward. Thank you.
It's kind of it's kind of one of those things that you see it, it makes sense, but when you got to do it on your own, it's always where it's a little dicey, because you're just, it's like you're kind of on an island. You got to be ready to do it on your own, and I mean, I remember when I took these classes and you see the instructor do it and you think, oh, that's not too bad, but
And you do it and it sucks.
it's a lot harder. Yeah. So a block of mass M is on a ramp that is inclined 20 degrees, is connected by a string to a block of mass M2 that hangs over the top edge of the ramp. The coefficient of friction between the incline is given. What is the acceleration, the mass, the tension of the string? Okay. So kind of the same problem as before. You end up treating the system as like you got to do this block and then you do this block.
Mm-hmm.
So it's going to be the same as before. So let's look at the one on the right because that's easier. The M2 is easier. Let's just focus on that one. So M2, what are the forces acting on M2?
The forces on M2, we got gravity and is it is acceleration on its side here?
Acceleration is not a force.
Not a force. All right, never mind. Gravity. And we got
Tension. That's
tension,
it. I mean,
okay.
it's suspended in the air. That's it. So it's so the which way is accelerating though?
So it's
And maybe we don't know actually. Mass 2 is 8, mass 1 is 5. We'll assume it's going down.
yeah, we're going.
It
That's
most
going to the
likely
right.
is, but it's not always the case.
Okay. You would assume though that the object with the heavier mass would be going.
Yeah, and even if you make a
north.
mistake, you can you can be dealt with in the middle of the problem. But
Uh-huh.
so it's like you don't have to get it. So let's do the sum of the force. So we're going to assume that the acceleration is this way. So that means that down is positive, and
Acceleration go down. We got tension.
so we got M2G minus T equals M2A.
All right, so yeah.
Is that okay for that part?
Yes, it makes sense.
That's the simpler one of the two.
And the mass here is 8, so we can plug it in. We can do 8g minus t equals 8 times a. We could solve for t, which will be like t equals, what would be in this case? It would be 8g minus 8a.
Yeah, you don't have to put the numbers in. You can. It's a lot of students do that. It's totally fine because there's subscripts. It's easier to identify between the two of them. So now let's look at M1. M1's more complicated. We were doing problems with M1 previous, but without the without it being attached to something.
Yeah.
So it's got other forces on it. So the first force is M1G down. Do you see that? Normal
Yes,
force
that.
up.
Oh, yeah.
Since it's accelerating to the right, the friction force is going this way. We'll call that force of friction. And then it's got tension going to the right.
Okay. This was the one thing in class that I didn't really understand.
Which part is the?
So we got. I think that this part is straightforward. It's the
Okay.
plugging in the equations with like the mu k with friction that's difficult for me.
Okay, so this one requires you to write two equations, one in the x direction and one in the y direction. And it doesn't matter which one, but let's do in the y direction first. So it's the sum of the forces equals mass times acceleration. It's not accelerating in the y direction. So mass times acceleration is 0. That's important to start with. Is that clear?
That is clear.
Okay, so what are the forces in the y direction? You got the normal force up. Okay, you got minus. Now the angle here is 20, which corresponds to the angle here 20. So it ends up being m1g cosine 20 going down.
So we got y direction, and so the force is 0 here, right? Because of
The sum of the forces is 0. There's no acceleration.
okay. So ma is 0. All right. So n is for normal force
Yep.
minus
So
and
this
m1g.
this is m1g cosine 20 going down
Okay.
because the other one is going in the y direction. Is that okay?
Yes, it is. So
Okay. So you can solve for n if you want here, and that's probably worth doing. N equals m1g cosine 20. You can get a number for that if you want, but it's not necessary at this point. We now need to go in the x direction. Since this thing is accelerating up the incline, we're choosing to the right to be positive.
okay.
And that's really important. So sorry, I scrolled too far here. So you just got to grab your forces. So T is positive, and then the force of friction is negative minus the force of friction. Minus, you got this m1g sine 20,
Mm-hmm.
m1g sine 20. And this thing is accelerating, so it is m1 times acceleration.
Cosine 20. Cosine 20. All right. So I got m1a.
So there's a lot of equations here. The force of friction is mu k times the normal force.
Okay.
And we have mu k, and the normal force is m1g cosine 20. So all of that, which is a number, and I know you probably want to put the number in, but I usually don't until the end. All of that goes there.
Oh, so it goes to the okay.
So it's T minus mu k m1g cosine 20 minus m1g sine 20 equals m1a.
Okay.
And that looks bad still, but you know mu k, you know m1, you know g, you know m1, you know g, and so on. We're going to bring down the equation that we just found going the other direction for the other part. So I'm going to bring that down. And what do we know about the tension in the two strings?
It's equal usually, right?
It's equal. So you have your choice here. You can, like, I'm going to solve this one for t. Okay. So this one, t equals m2g minus m2a. This I'm going to bring up and put into this equation. You know, now I know it
Okay.
looks bad. I know it looks bad, but you have everything now. You have m2g minus m2a minus mu k m1g cosine 20 minus m1g sine 20 equals m1a. The only thing that you don't know here is a, and that's what you can solve for.
Oh, okay.
So I'm going to move
M2G.
M2A over to the other side of the equation. So you're going to get M2G minus mu k M1G cosine 20 minus M1G sine 20 equals M1A plus M2A. If you factor out an A from both of these and then divide by M1 plus M2, you get your acceleration. So that we're going to bring down here, and we're going to divide that by M1 plus M2, and you have your answer. Now keep in mind, you could have put these numbers in all along. You'll probably do that on the test, but higher level physics, you don't put the numbers in until the end.
Okay. So we got A equals M2 minus UK M1G cosine 20 minus M1G sine 20. We divide this all by M1 plus M2. And now I can do acceleration equals 8 minus, is that 0.22?
Yep.
Cosine 20 minus sine 20. Is that 3 plus 8?
5 plus 8. That's just the other
Alright.
masses.
5 plus 8. All right, let's see if I can put this into the calculator correctly
Okay.
now.
Yeah, that's part of the challenge here.
Because I had negative 1.45. Oh,
Yeah,
I'm
so
putting it correctly.
a couple things with that. I'm a little surprised that it's negative, but here's what that means. It means that we chose the wrong direction. It actually does not slide down.
Oh,
It means it actually accelerates the other way. Actually, or the mass 2 doesn't pull it down. It actually goes
goes
up,
up.
which is what happens when you choose the wrong direction. But as long, see, we were consistent. We said, oh, we think it goes down here, and then it goes up on this ramp. If you had mixed them, you would get totally the wrong number. So I'll assume that's right, unless you got the answers.
Uh-huh.
If you don't have them, we'll just go with that. And the tension is the next thing we can calculate. The tension we can grab from either of the equations. I'll grab one down here. So, oops, I don't know why it did that.
I'm just going to put T equals M2G minus M2A.
Yes, that's the one I was trying to grab. Like that
And the
one a
mass
lot.
2 is, what you call it? It's 8. 8 times 9.8 minus 8 times negative 1.45, right?
Yes. So it's whatever it is. It's mass 2 is
All right, I get 90.
okay. So about 90 newtons. Okay.
Have you done it wrong if the Newton is if Newtons are negative?
Yeah, that one for sure would be wrong because the tension has to be going. We can choose the right direction for tension.
Okay.
I mean, that would assume tension is going like into the block, which doesn't happen. Okay, so we can talk about part B. We're kind of gonna restart the problem here a little bit, but it's good to do this again because this is a very sophisticated problem. It's got a lot to it. You're not gonna just
Magically get it.
yeah. So the mass 1 is 8 this time. Mass 2 is 8, and mu s is 0.3. So if it will not slide up the incline, which that still sort of bothers me because our acceleration, we had an issue with acceleration, but that means that there's no acceleration. So this is actually a simpler problem than the previous one because you don't have to. Oh, actually, we don't know M2. Well, we're solving for M2. So there's no acceleration. So this time when we do a free body diagram on M2,
Wait,
and
backtrack. Why doesn't it have any acceleration in it?
because it says it will not make M1 slide up the incline. So if it's not sliding, it's not moving. That means there's no acceleration.
Oh, so there's nothing happening to it.
Nothing
Okay.
happening. Yeah. Okay. So the direction is now arbitrary. You can say t minus m2g equals 0. So t equals m2g. Great. Now we can look at m1. M1 is m1g, normal force. There's a force of friction, and then tension to the right.
Okay.
So this time in both the x and the y direction, it's not moving, which is pretty helpful. Sorry, I just can't quite get it to get right to where I can. Okay, so in the x direction, actually let's do the y direction first. The y direction, you have n minus, and this is 20 degrees again, m1g cosine 20 equals 0. So it's the same as before. N equals m1g cosine 20. In the x direction, though, there's no mass times acceleration. So you're just grabbing the forces in the x direction. You got, we'll choose to the right to be positive again, just arbitrarily. So t minus the force of friction minus m1g sine 20 equals 0. So basically the same as before, except there's no acceleration.
Okay. So F friction minus m1g sine 20 equals 0. All right.
So you again say, okay, force of friction is mu s times n, which is mu s times m1g cosine 20. So that's t minus mu s m1g cosine 20 minus m1g sine 20 equals 0. And then we know that tension is m2g from up there. So we can substitute that in here. So m2g minus mu s m1g cosine 20 minus m1g sine 20 equals 0. The only value that we don't know is m2.
Okay.
So we can solve for m2. So m2 equals mu s m1g cosine 20 plus m1g sine 20 divided by g. And that's just algebra. There's nothing sophisticated or complicated on this.
So we're looking for M2, right?
Yeah.
And what's mu s in this case?
The coefficient of static friction, and it's given in the problem. It's mu. It's 0.3. So it's
So it's a bunch of symbols until the end, and then you plug in all the numbers.
Yep.
So 0.3 times 8 times 9.8 cosine 20 plus is it 8 times 9.8 that's 20. All right.
A lot of mistakes are made just putting this in the calculator.
Yeah, that's why I'm doing it individually. That's something I'm trying to be careful about.
So this equals about 5, which is interesting.
Yeah, I get that too. So M2 equals 5. What would this unit be?
It's a mass, so you can always go back to your SI units, which is kilograms.
kg. That's funny. That's basically the same as M1.
Yeah, they're probably trying to show you something with that. Maybe there'll be a comment in class tomorrow.
Hopefully, yeah. All right.
Okay, should we move to 11?
Yes.
All right. Do you have other stuff for the second hour, or was this it?
I kind of want to go through this, and I wanted to show you a problem with the Atwood machine that I just really did not understand.
Okay.
This isn't it. All I want to do.
All right. So in the diagram at right, mass 2 is 20 kilograms, and there's a friction force on the incline. So what it's saying is like it could either be 30 newtons to the left or 30 newtons to the right, depending on which way it's moving. Because it's in newtons, it's already accounting for the normal force and mu s/k. Like you don't have to do all that. It just gives you that number.
Oh, okay.
It says if M1 is heavy enough, M2 will start to accelerate up the incline. And if it's not heavy enough, well, it'll accelerate down the incline. So we're trying to figure out like what is that break even point, essentially. Is that okay? Like
Still, it's like foggy for me.
Well, there's a value of M1 where this thing doesn't move.
Okay.
And then if M1 is lighter than that, it will come up. And if
Yeah,
M1
it'll
is
start to
heavier than
move.
that, it'll come down.
All right. So we're trying to find like that sweet spot where it just keeps it like.
Yeah.
All right. So that's what we're looking for. Okay.
Yeah, so let's assume if this thing was gonna if M1 was what is the maximum value M1 can have without M2 sliding up the incline. So if this thing were going to move to the right, the friction is opposing the motion this way.
Okay.
Okay. So let's draw a free body diagram on M1.
Mm-hmm.
So we have tension up, M1G down. So we have T minus M1G equals 0. So that means that T equals M1G.
Okay, so T minus M1G. All right.
I should probably make this clear. Like, we're basically going to do one problem where the force is going down and then the other force is going up.
Going up. Oh, all right.
That's all really the differences. So for M2, you have M2 down, but it creates this triangle. You have your normal force up and your tension to the right. So what some students do is they actually immediately write M1G up here because that's what it is. It's from this other one,
Mm-hmm.
this other part of it. Okay, so then let's go in the x direction, because that's the only one that we care about. Sum of the force in the x direction equals mass times acceleration, except it's not moving. So we have we'll choose I don't know. We'll choose right as being positive. So T is positive, which is really M1G, but I'll just leave it as T for the moment. Minus the 30 newtons, because that's opposing, it's going that direction. Minus, and then this is where you gotta break that M2G into its horizontal and vertical components. So we got M2G sine 20
Mm-hmm.
equal to 0.
M2G sine 20 equals 0. All right. Are we solving for tension here again?
No, we have tension. Tension is M1G. So we can say M1G minus 30 minus M2G sine 20 equals 0. We're trying to find M1 in
All
this
right.
case. So M1 equals 30 plus M2G sine 20 all over G.
30 plus M2G sine 20 over G. All right. Let's see if I know which one to put in there. So, what do I do here? What's the unit for M2G in here?
The units of M2?
Yeah.
Mass is always in kilograms. G is in meters per second squared.
Mm-hmm.
I know we got a late start here, but I got to run through the rest of this problem, and then we got to just pause for like 10 minutes for my sake to help here. So the only different in the part 2 of the problem is that the this line. So in part 2, T, it becomes plus 30 minus M2G sine 20, and that's because it's going in the opposite direction.
Mm-hmm. Oh, by the way, what are the numbers that I put in for M2G sine 20?
M2 is 20 and G is 9.8.
Oh, okay.
And then this is oops, that's not it, equals 0. So then T again is M1G plus 30 minus M2G sine 20. So your M1 equals M2G sine 20 minus 30 over G. It's 30. So this ends up being about 3.8 kilograms. So like, then the point is anything in between these two values, it won't move. And anything outside of them, you'll see movement.
Oh, okay.
So we do have to stop, and I'll restart the next one in about 10 minutes. We can keep going on this if you want, or we can do whatever you want, but I do need a short break here.
All right, that's fine.
All right. Thanks, Jack. I'll talk to you soon.